My name is 𝗬𝗏𝗰𝗀𝗲𝗏𝗏 and I'm the Key Account Manager at BuildingPoint. We are very happy to have Thorsten Hertel from Trimble with us today and share his knowledge and view about this topic.
Right, thank you very much. Also from my side, very good morning, and thank you to the colleagues from BuildingPoint Scandinavia for having me today presenting this exciting, hopefully very insightful precast manufacturing related topics presented to you. Agenda-wise, what do I have in mind to present you today? So these are the 6 elements we want to go through in today's presentation. And since we are having here this framed with Norway specifically, I want to give you a little bit of a retro perspective on the Norwegian market and the BIM or BIM usage, how it has looked or how it looks today. Maybe as a little bit of a retro perspective or a status quo, these kind of visualizations are kind of items to say this is the future of connected construction, this is the future of BIM. And when you read these particular boxes and you browse through, you will see, well, yeah, actually this doesn't sound so kind of unfamiliar. There are many things which we, and I hope you do as of today or thinking of doing this. And this is actually a very good thing that these kind of predicted developments have actually come to our daily life, so to speak, and we are using this to a certain extent or even full-fledged and seeing great benefits of this. And from another aspect, talking about the life cycle when it comes to building information modeling, all these kind of predicted things what building information modeling would bring us as a benefit are in fact these what we do today. And we have also for a long time as saying Tekla structures being a BIM solution since ever been stating this, there is the benefit of doing this 3D modeling and having all the information stored, and then over lifetime you will have a payback of the additional, you might say, work in certain aspects, but in the end you get really more out of this by doing more with the actual model. And coming back to Norway, as a very kind of a spearhead country also in terms of the BIM adoption, you have the open or the BIM mandate since 2016, which is significant. So you have a governmental body requiring this also. So the whole framework basically is a very positive aspect in Norway. And I'm also, when working with Norwegian customers and prospects, I'm always seeing this as a very positive way to come to people who say, well, yeah, building information modeling makes sense to me. I want to utilize this more because I do understand the value of this. And so I'm saying that you are definitely on the forefront, and you're also giving a great example to other companies which might not be yet on that same level as you are in the adoption of BIM. So that's a very positive aspect you can put on your badge and saying, yes, we in Norway, we are doing these things already to a vast extent, and that's a great thing. And so now, how do I come from this BIM adoption in Europe and Norway to this fabrication part? Because this BIM adoption is also a key element for this automated fabrication, where you see your benefits coming through. But a quick start also in that sense to undermine where this all comes together. This is a big piece of puzzle. When we see Tekla structures evolution here, so when we started in the early 80s with the product, and when it comes to interoperability as a highlight, which we are now basically taking as a guiding path in this presentation, we put already a lot of emphasis on this interoperability part in the early 2000s. So this is one key element. And the other things which are highlighted here are as these features what you're using today and giving you the benefits to that extent you can use the software and you see best fit, especially with the OpenAI, which provides you a great opportunity even to extend this very comprehensive solution towards even more specific needs you may have. Another thing what we over years now improved for those who are using Tekla structures and knowing the product for quite a while, we have changed our kind of configuration base. Previously, we had more than 10 configurations. Nowadays, we're having the subscription model and coming with 3 subscription models, carbon, graphite, and diamond. And why I'm specifically mentioning this is we also have great benefits with these provided. So you don't have to have a specific configuration from the old times, if I may say so, in order to make benefit of data which someone else contributed to. Now you have really 3D configurations, more or less. They give you full access to the information in the model, on the drawings. And this makes the life much, much easier, and also helps you from a role-based perspective to get even more out of Tekla structures, and serves you way better than ever before. In this all, the intent is to highly constructible models, just to benefit from this in every possible way. And when we talk about the precast fabrication or the automated fabrication, the detail matters. So the more we have in the model concrete information, the more it also plays back in a positive sense towards the fabrication. And one key element, just to make a clear statement, this solution, as mentioned earlier, was a BIM software by its heart when it was created. And over time, we have, of course, enlarged functionality. A very important takeaway is that this is all a solution which was made from the bottom up for the purpose. And it's not just a platform to which we put some certain functionality and try to mimic something. So the key element here is that's from the core, it is the industry solution adopted, that you have the numbering, the drawing creation, etc., the extensibility, and especially nowadays, and we will come to this later, when it comes to the cloud services, that this is also in a meaningful way connected and not just a Dropbox feature, with all respect said, where you host your data somewhere else instead of having it connected in a meaningful way with your actual authoring software. But okay, this as the starting point in order to get a little bit the groundwork done. Now let's move on to the actual precast fabrication part of the story, so that we get actually the essence of this webinar a little bit covered. And I would like to start with the ERP part, or the enterprise resource planning part, because that has over time evolved a lot. Looking back at my career, or my part where I've been helping around the world integrating Tekla structures to automation systems, over time the recognition of the value of ERP has risen significantly. And say, many years back, it wasn't quite typical that people from the ERP part were sitting in business meetings to basically bring forward their requirements and needs when it was about integration of Tekla structures and the automated fabrication. But with the understanding of BIM, the building information modeling, and the value which is in the 3D model, it was also way more clearer that ERP part, with all these basically outline possibilities of the ERP functionality, it's kind of an essence to have an early stage discussion with ERP personnel, respectively software part, in order also to connect in a meaningful way and get even more out of this. So that you are not just thinking of fabrication, also the whole procurement, the whole delivery part, and especially the financing and stockyard management is also well captured, so that you get even the greatest benefits out from that angle. So in that sense, I'm seeing this nowadays as a very integrated part, that you have your fabrication, your detailing, your fabrication aspect also consolidated with an ERP part, so that you have in an early phase already the possibility to get access to data and make meaningful moves forward based on the data. And here, maybe as an example, how an example customer may work, and having here a scenario drawn in that sense. So we might start from the architecture side, that we have 2D drawings from the architect. We might integrate this or import this in Tekla structures, doing the actual 3D modeling, creating the 3D models with all the details. And at that point already, for quality and material takeoff, you can already integrate towards an ERP part, where here as an example would be SAP. And then depending on the setup, it might be the actual entity in the process pushing forward the production data towards an MES, and I will get back to this in a moment, or even then to the manufacturing part of reinforcement. This is all a kind of an integrated workflow, which brings the actual thing to a meaningful way to say, when I'm starting to detail and I'm adding information, who else could benefit from this? That this is not just a single way, this is a connected way, once again, to get the most out of this effort of detailing and having the information captured. And just to give you an explanation, what kind of options you basically have from the detailing Tekla structure side towards an ERP. SAP is a very prominent ERP solution. What kind of magic you would need to do on the Tekla structure side to get data out? First and foremost, these ERPs in kind of retro perspective have always been in the position to read ASCII files, basic text files. And here with the Tekla structures integrated reporting or with the organizer, you're in a very good position just to create basically the information in a structured way and pass that on to the ERP side in a very customizable level, because there is no basic standard to say there's an SAP file, I need to export this in schema A or B. This is always a very specific setup by the company who is basically having the ERP software running. Another part would be here when we are using the fabrication ERP from Elematic. For this, we even have a very dedicated and special export where you have the fabrication data enriched with all the necessary metadata, and you can put this out with the 𝗖𝗂𝗏𝗏 file towards 𝗖𝗂𝗏𝗏, where you have the possibility then on a full-fledged control software from start to end to make use of the data. I will come back to that also. Another interesting example here is 𝗍𝗍𝗃. That's a German precast production planning software. Also for this, are export specifically available in order to have here a streamlined process working towards an ERP solution, which is entirely made for the precast fabrication side. And maybe last but not least, in this kind of scenario, to explain where the ERP part is integrated, a very prominent player in the market is i2 from RIB SAA, or IRB specifically being the company behind i2. And over time, they also joined forces with SAA, which is an MES provider. And the creation of the software based on i2 turned then later into this production planning software and manufacturing execution software. And also for this, we have, when it comes to ERP, specific exports, which then extracts the information out of the BIM model in the expected and required data format, so that once again, on their ERP side, they can do the production planning, and eventually also, depending on the configuration on i2, you can even do 5D-driven project planning. So in summary, basically just to scratch a little bit on the subject of ERP, which is a really large entity, and it's always a kind of to be customized situation. One doesn't fit all. Just to take away saying there are clearly possibilities, ready-made possibilities to extract Tekla structures data from a precast perspective towards ERP solutions in order to make more value out of the model what you are creating. Then actually working forward to the production planning aspect. And that is a very essential part when we are going towards more the fabrication side and making, once again, essential use of the data, what we've been creating. So production planning, in that sense, as a kind of a headline, incorporates a lot of things, specifically now breaking it down to the aspect of saying, we want to help the production to plan their actions. And the two items what I'm here basically emphasizing is here, left-hand side is the transportation. Here an example of hollow cores being transported. On the other side here, look into a factory where we have, in that sense, non-automated process, but having the tables and then having wall and slab or these kind of products fabrication, where you also need to do a planning, how you do most efficiently the layout on the elements you want to manufacture. So from a Tekla structures perspective, how do we help you out there? This here is a simplified process, how you would do this basically. It is very straightforward, and I said simplified. The key aspect is that you have basically your Tekla structures model, you do your detailing, you do your full-fledged operation on that part, and then when it comes to the actual planning point, you are extracting the information in order to do a planning on a visual way, so that you, in that sense, have a clear understanding what are your means of transportation. And here is an example with double walls. Here is an kind of giving you an idea how the transportation could work. And transportation works in various ways around the globe. So here on the left-hand side, you have an A-rack, and then you have here on the right-hand side, the inside loader. These kind of, depending on what you choose to transport product-wise and what are your kind of products, so to speak, and which kind of procedure you have. And in that sense, we are very flexible in that sense. We, from the software point of view, what we have is called Stacker. You have a tool where you can actually create your transportation units or the racks to yourself and can import them. So you're not there set on a static definition how you can transport. And you have a graphical driven environment where you can, based on the model data, do your planning of transportation. So on the right-hand side in this image, there you see the stacker, where you already see that there's a trailer being used, for which you have also conditions defined. What's the maximal loading and what can I basically do on a distribution, the center of gravity, the cast unit information, all is there. So this is on the model-based information level exported. And all these informations which you are there basically working with in the stacker, they are also driven back to the model. So this is a completely connected workflow that whatever you do, it goes hand in hand. Whatever change you make, it goes back to the model, so that you always have, from a BIM perspective, from our side, always having the center is the model. It's also one truth that you don't have, in that sense, split information and later on having difficulties to update when it comes to changes, which is a quite natural thing in our world of engineering. Then palletizing. Also here, we have a similar workflow that you basically do your detailing to that extent as you usually do. And then you want to do more of a support towards the fabrication. You will extract in a similar manner as with the stacker, the information, so that you do this on a visual level as well. So here, in that sense, you have various ways to address pallets or the tables, you may want to say. And then the products can be aligned automatically, can be turned and shifted, and information can be, in that sense, hidden or excluded so that you don't have to have all the details. So we are reflecting here to fabrication needs also in that sense that the tool has really a lot of functionality to optimize the workflow to your personal needs. And that's the same procedure as these palletizing and stacking features are kind of going hand in hand, that you also have a similar functionality on the palletizing part to optimize your fabrication. Here also there's an automated functionality which makes the distribution among the tables so that you have the best fit, what fits best among the tables, also considering then the fabrication dates, so that this is an optimal outcome to come. Maybe as a word to raise this here in regards to these production systems. When I will come to this in a moment, when you see fabrication systems where you have way more functionality towards this production planning, we are not going into competition in this regard with this functionality. Here we are targeting primarily those who don't have necessarily the full-fledged fabrication systems, so that you have something. Think of those in the picture seen before. You have a situation that you don't have automated fabrication, but you do have 20 tables, and you do need to have an understanding how you optimize the placement, how you make the most out of this. So these tools come in pretty handy. And also with the truck transportation, you can think of ship transportation, cargo container, railway transportation, all these things you can basically handle with the stacker. You can even then create these things as you wish and use this in a best possible way. It serves your purpose. So this is just to undermine a little bit or explain the situation, why we not necessarily want to go into competition with these production planning solutions which are out there and we cooperate with. This is here to support the workflow in the most meaningful way, also to those who are not having a fully automated workflow. As this needs to be understood, automated fabrication is a costly investment, but it is, of course, a very meaningful investment. But there are various ways to accomplish things, and especially it has always to be seen to the products you manufacture and how you want to deal with this. So this, in summary, about the production planning. This is, of course, way more of a topic to talk about more and go into detail, but maybe just scratching the surface to give you a kind of an idea, and we can go separately into more details if you have interest. Finally, when we have this kind of scenarios, and I think this is a very important aspect when it comes to bring these different roles also together to understand that this is basically should be and can be a team effort, that there is not an isolated detailer which creates the actual model and passes on the information to someone else whose role is to do the operations for the fabrication or for the transportation. With our configuration scenario, this all can be combined. And here, as a kind of in a simplified way to visualize this, we have Tekla structures model as the core, and all these here 4 examples of roles are working simultaneously. That's important, simultaneously on that specific project, and can contribute from one each other in terms of information, so that there's the best possible outcome. And that is also a wonderful thing initiated through Tekla model sharing, that you, regardless where you are on this globe, you could do the simultaneous work, of course offline as well, in order to really have this one source of truth and get your required data out in the most possible and meaningful way, without having necessarily to contact, here in that example, the detailer to ask for information. Say, for instance, can you export now stack data? Can you export now palletizing information? Whereas this specific person could do this entirely by him or herself in order to get the most out, especially then also with the fabrication data, to which we are coming now in a moment. So production and fabrication, kind of the premium part of the automated world. There are many facets to this. So on the left-hand side, a highly automated factory, you won't see much of workers. On the right-hand side, also highly optimized and driven to very few people in the factory. Left-hand side, structural elements like half slabs, double walls, etc. On the right-hand side, we use the example of hollow cores. Before I get into the subject itself, maybe a quick introduction on abbreviation and file formats, which I'm using here in order to give a little bit of an insight what we are actually dealing with. So the 𝗵𝗵𝗶𝗴 file format, it's kind of a very long-standing entity in the industry. This is kind of the format when it comes to cut and bend reinforcement, and it has been recently updated a couple of years ago, but otherwise this format has been nearly for 20 years untouched, because it was well engineered and it has been served the purpose perfectly. So maybe 4 years ago there has been a slight update on the schema, on the format, but otherwise this just runs furthermore as it is, and it has provided the necessary benefits throughout the world, even to say. So it has been also highly adopted outside of Europe. MES, I have mentioned this earlier. What is an MES? A manufacturing execution system. So here from a picture, you see how a workstation could look like of someone who sits in the factory and is the factory manager or operation manager controlling the actual automated fabrication. Think a little bit of the automobile industry, where things moving around controlled in just-in-time operations, and that would be kind of the analogy to the precast worlds that you have here, visualization of the processes and connected interactions based on the different steps within the fabrication. So this is all managed by a MES, a master computer is the other word, which is well established in the industry to operate this fabrication. This fabrication all requires data, and that's the data what comes from the BIM software. And what format are we using for this? And here, let's call it the father, less of a coincidence. This has been there since the 80s, the Unitechnic file format, and it's still live and kicking, if I may say so. The format is around, as said, more than a while. It has evolved. Originally, it was a 2D format, and it was somehow constrained to a maximum of a 200D, 2.5D information level. But also here, there's an update made. Nowadays, we can also do this in 3D, and then the actual format is changed a little bit in a sense that previously it was an ASCII text file, and nowadays it's the modern version is XML based. So there's an evolution also in that sense, in order to help to evolve also in the fabrication purposes to be more modern. So, but Unitechnik is one of the most used file formats for the precast automation in the world. Then another one, which is relatively new to the precast industry, whereas the file format or the schema itself is around for quite a long time, the IFC, which means industry foundation classes. Specifically here mentioned, IFC is around for quite a while and been used as a collaboration format in the AEC world, very well adapted and very well accepted and also very mature. However, it hasn't served the purpose of fabrication. This wasn't an intent in the first place, but also here there's an evolution, and I will come to this in a moment. One key element here to take away, it's a standard. So this is an ISO standard. So that means this is also worldwide accepted, and it is not just one supplier or one vendor dealing with this. So this is really one wonderful thing to connect the worlds in a very constructive and meaningful way. And once again, a great transponder of BIM information, modeling information. So bigger picture on the production and fabrication side, when we look from Tekla Structures point of view, and we are looking at various products, how to communicate this, and also, of course, the purpose of having a file format has a reason, because we want to provide data, production data, to various systems to make the most out of this. So simple pictures. You may not read well from the screen the different file formats, but the point should be here to say, you have different products to manufacture, you have different machines, you have different manufacturers, we have different file formats. We are well situated with this, and we are covering this all with the functionality of Tekla Structures, so that nearly everything in the process is optimized and full-fledged supported. But let's go in a bit of a practical approach of this, and starting with 𝗵𝗵𝗹𝗶𝗴 when it comes to cut and bend. And here specifically in the Nordics, this has gained ground again, which is nice. As I said, this is a very respectfully saying old format, but still very much used, or even more used nowadays when it comes to the BIM aspect. So 𝗵𝗵𝗹𝗶𝗴 has been generically driven by the aspect of having a bar bending schedule in a drawing, and then making use out of this when we have a digital workflow, that this information of a bar bending schedule is transferred in a machine readable format. And that's here what you see, 𝗵𝗵𝗹𝗶𝗴 file. That's basically the translation of a bar bending shape into machine readable definition. So here in that sense, as the point would be here, the machine, you see a terminal, depending on the structure of the IT structure or the setup itself, you might go there with a USB stick and upload the 𝗵𝗵𝗹𝗶𝗴, or you have a network connected and you push this right away to the terminal and you upload it to the machine, and the machine starts working. But that's basically how it was driven in the past, so to speak, that you have a drawing, you have a bar bending schedule, either someone types in information at the terminal or you're uploading the file to the terminal. Now, past years with understanding of IFC also in the usage, that the aspect was, well, we have IFC, we can see the models, we can see basically everything in a very neatly visualized way. Why couldn't we now have the fabrication data also connected? And there was the idea born to say, so well, not then why not adding 𝗵𝗵𝗹𝗶𝗴 data as part of the IFC? And that has recently found interesting aspects. So what you can do with an extension, you can basically enrich your IFC file with 𝗵𝗵𝗹𝗶 data, so that you are now in the position to manage your 3D model in a sense that you extract from the 3D model your 𝗵𝗵𝗹𝗶s data as it is integrated into into the IFC file, and gives you then the possibility, for instance, with Trimble Connect, I mentioned this later again, or with other tools like from Solipri, you have the possibility to extract information out of the IFC file, such as the 𝗵𝗵𝗹s data, in order to initiate then the fabrication. The 𝗵𝗵𝗹s file as an output will be the same as in the old times, but you have driven it here from an IFC file instead of a bar bending schedule or a drawing or elsewhere. So that's a quite of a neat way to combine the visuals with the fabrication data. All right, another aspect of fabrication, and that's also well established in the Nordics, Scandinavia, is the fabrication of hollow cores. And I'm using here specifically the Elematic fabrication side. So here, hollow core as an example with recesses, openings, lifting loops, and eventually then of course, very much strands attached and additional reinforcement. Here we have a very sophisticated and mature export also towards the fabrication system, which you see in the background by the identified in color green of Elematic. You see there the bed layout where the software is doing the full-fledged planning based on the fabrication data we are bringing in from Tekla structures. So here on the left-hand side, you see an extruder where on a hall you see an extruded hollow core, say up to 180 to 200 meter continuous hollow core, which is then automated, plotted, the cuts, the openings, and of course the particular information on the hollow core itself, what cast unit, fully automated based on the fabrication data. So that's a well-established workflow. It's highly efficient and it's top quality, since you don't run around anymore with measuring tapes and you spray on the concrete where you want to have a cut, as there's also automatic machinery for cutting the hollow cores, as well as the openings, like for lifting loops. What you see here in the picture, that there's a device which is automatically taking the concrete off. Then the lifter is placed and concrete is put back. This is also highly automated. And once again, this is basically the data you get out of the BIM software Tekla structures, which is one-to-one used in the fabrication software here from Elematic, say plant control or flow MES. Then moving on more to the side of this fully integrated or full-fledged MES software side, where you have here operator sitting in front of a master computer. Here the picture is from Unitechnic, Unichem, the master computer doing the operations in the factory. So this is then in practice a bigger operation. So you have here, playing this a little bit through to visualize this a little bit more, in a sense that you have here the detailing office, which then extracts the information as a Unitechnic file to the master computer, which then has, for instance, here a plotter. You see on the right-hand side, the assembling part, a plotter plotting the outline of the geometry, then also doing the automated shuttering, placement of things. You have reinforcement machinery, which is once again controlled by the Unitechnic data to do automated mesh, and as well with all the information, the concreting, that you have the possibility to fully control here the distribution of the concrete. Plotting, shuttering, the laser projection, and the placement. This is a full-fledged operation on this master computer. So that's a very costly, if I may say, investment. But if you're really having a full-fledged fabrication of standard elements, that's the way to go. Right, and what are these aspects of this? For instance, you don't have to have always the thought that you have to have a full-fledged fabrication or automation part. So this can also be done in pieces or in steps, that you also have an evolution. And one wonderful thing here, for instance, is the laser projection to reduce errors or effort in the fabrication environment to get the formwork placed or embeds placed. So these lasers on a quite affordable level. So you might have an investment around about 20,000 euros for a laser, which then gives you, based once again on the CAD data, and you see here an image, the possibility to make use of this BIM model in order to project, in that sense, like in a catalog system, the various entities. So you have an operator with a remote control, which might then just cycle through the various entities to be projected to say, show me now the elements, the spacers to be placed for the windows, for the doors, or lifting loops, and this can all be done quite neatly and efficiently. And it's a relatively low investment and a great added value in fabrication and cost saver. So here are some practical pictures how this looks like. The newer modern versions coming with more colors. Previously it was more reduced to the green laser. Nowadays it can be also with 3 colors. So it is more versatile nowadays. A quite interesting thing as it works in almost any kind of fabrication setup where you can statically install your laser to the roof or as on a table as an extension. All right, so then let's go a little bit more into this kind of more concrete automation output. How does this work in practice? Per se, here we have a Tekla structures wall with all the typical elements named here. And what could I do with this? Well, I have basically my 3D model, and I'm now putting this out as a Unitechnik file. I have a really comprehensive and feature-rich export. And here I'm also taking the opportunity to mention another file format, that's PXML. That's the precast production export tool which we have for this. That's Progress. Progress is another machinery and software provider which has a file format established which takes Unitechnik as the base and has it enriched to the level of their capabilities, what the machinery can do more than what the Unitechnik file format as a standard supports. So these two are kind of the leading formats more or less in the industry. So I'm exporting this now. And in Unitechnik terms, I'm breaking this down into a 2D representation for fabrication. So this is basically a visualized Unitechnik file of that particular wall, what I showed you. And here's the legacy Unitechnik viewer, giving you then kind of the possibility to visualize the data you've been exporting in order to make sure that everything looks okay, is okay, before you pass it on to fabrication. And this has all a meaning. As previously pointed out in the image here, we have a clear instruction, or there is a schema which clearly defines these are contours and openings. Then we have formwork and embeds. These are all categorized so that you also have a clear understanding what you actually export with all the characteristics and production data related scope of metadata. And especially reinforcement as Unitechnik file format is also being used for automated mesh welding machinery. And that it looks like this. This is the modern version of Unitechnik file format UXML. That's the XML based, which then also goes more into the 3D world, so that you have here your representation of the production data in 3D scale to even get better understanding if everything is done correctly towards the fabrication. Now, the new kid on the block when it comes to fabrication, and I mentioned now basically the establishment and the majority of the automation systems out there are driven on Unitechnik file format and PXML driven interoperability. But the limitation to this is that you always need to incorporate the fabrication setup, meaning that when I'm exporting something, I need to know to which factory with what setup the factory is, and I need to incorporate this in my design and also in my export, that I'm reflecting these particular constraints what I may have in the factory. That makes it difficult, for instance, to react to a situation where I have, say, an overload in the factory, previously planned to extract my data for factory A, but now needs to do this for factory B. Problem is that the setup of factory B is different than factory A. So I need to basically go back to the detailing part and say, can you please modify your setup so that it fits the setup of factory B, because I can't manufacture in factory A. So this problem has become an industry problem when you run multiple factories as a bigger organization. And so the thinking was made, well, is there anything better out there where we can reflect this in a sense that can't we shift this kind of operation-specific thinking into that place where it belongs to, into this MES part in the factory system? Yeah, how? Well, actually, good idea. Why not using IFC for that purpose? Because we have the full-fledged model, all the information we have there, and good, but we don't have the fabrication specific alignment with this because IFC wasn't made for that. So at that point, then industry leaders came together, and under a Building Smart International umbrella, the IFC for Precast initiative was created. And by that effort, we have nowadays the IFC for Precast, which is an IFC 4 based model view definition, which serves the industry, the precast and the rebar detailing industry. So this is now the solution to use IFC4 for the precast fabrication. And in that sense, also saying this is the link to that effort what has been made towards combining IFC with 𝗵𝗵𝗹𝗶𝗴. I see this respectfully as an intermediate solution because that IFC for precast has already in the beginning taken this into account to say we are not only taking the fabrication related information into account for the cast unit for the embeds, no, also for the reinforcement. It has to have everything in one. So that these rebar and mesh related information are also well captured in this IFC for precast aspect. So in that sense, over time, this 𝗵𝗵𝗹𝗶𝗴 might shrink a little bit to what specific needs, whereas this IFC for precast will be over time be the successor of the established file formats as well as the 𝗵𝗵𝗹𝗶 format. So how does that work? So similar to Unitechnic, as of course we are not cutting all strings entirely, we are taking the best of all the known good processes and try to enrich this even better to IFC for precast. So we're dealing here with the same kind of categories of things. And having here, and that's the added value, especially when we think about BIM, we have the objects with characteristics and with attributes, all by definition, and we can enrich this along the way to the most possible extent. And then when I'm exporting this, so this here is an IFC for precast element, and I have exactly the same information, full-fledged 3D, all the information in the IFC file, which then, with all these things mentioned before, goes right out to the fabrication system. So the fabrication system is then in the position to read these IFC for precast files and takes this as the input in order to do what it has been done all the decades before with Unitechnic or PXML, excuse me, to do the fabrication related task. But this time it does it based on IFC4 and has there with a totally different approach towards the information, because we can release basically this effort of putting all the constraints into the Unitechnic or PXML file. We concentrate here on the actual detailing, the necessary information from the 3D model, exported as IFC, so that the fabrication system is in the position to make the best possible judgment on how do I manufacture this based on the geometry, based on the metadata. And that is a totally different thing. This is a game changer in the industry to definitely have more high quality and eventually also faster production than what we had in the past. So with that, more or less concluding a little bit on the production and fabrication part, that we basically have everything here captured under this kind of big headlines. There's way more to explain, but in this given time, we can of course only scratch the surface. Then moving on to that part in terms of where the industry is also moving towards the cloud. It's no news to you, certainly, that a lot of things are shifting from the desktop to the cloud. Also, the industry in that sense need corresponding features and functionality where it makes sense. And from Trimble's point of view, we have also our kind of collaboration platform. It's called Trimble Connect. And I do believe that many of you have already seen use of this or make daily use of this. So this is a wonderful tool which also has the capability to extend functionality along the way, which is a wonderful tool also to collaborate with other stakeholders on a virtual way, meaning that you also have the drawings, but you also, key element is the model, and also to collaborate in a way that you don't need to explain too much. You just see and familiarize yourself with the information in the most possible way. And a great thing here as well, like I started in the beginning, ERP parts as an example, This all comes together seeing Trimble Connect as a kiosk, where you basically have all the stakeholders from different systems also to connect it, because what is Trimble Connect? It's a collaboration platform, but it's also a platform where the data is hosted, where you have also access to the data and can make use out of this. Another very important and very valuable thing in terms of the Trimble Connect technology, what we provide, is the status sharing. As a kind of, say, generic entity for many, without a specific color of trade or a function or role, statuses do concern us all. And we have a wonderful feature there on the Trimble Connect side and on Tekla structure side and others to share statuses in real time. So this is a feature, if you haven't seen it yet or haven't used this, I definitely recommend you to take a closer look, which is also customizable for your specific needs, to make use of the data which others have actually provided, so that you are up to date on any place in this world to see where your project is, and you can contribute back where your actions are basically related to the model to keep everyone up to date and make educated decisions based on information and not outdated information.
I also want to mention applications BuildingPoint has developed. So we have developed something called Trimble Connect REBAR label. It's a tool to organize the Trimble Connect model for easy handling rebars on the site or in the factory. Sorted the data based on different UDAs in the model. Then we have the next, the Trimble Connect Planner extension. We have many times been asked if we can do 3D visual planning, and now we can do it in the Planner extension. You can see the model, you have the calendar, and you can schedule the erection visually in Trimble Connect.
Then maybe mixed reality as a kind of more or less closing word to this aspect. So we are still in an evolution phase with the mixed reality, and I'm using here just a picture where the HoloLens being used, and nowadays there's different technology, just to bring this picture in mind and saying we in the industry, we're working in an environment which is not necessarily always warm and nicely illuminated, and there are difficulties, a lot of constraints. But even there's way to bring digital aspects into the world to enrich the actual way of working. So you don't have to have a HoloLens anymore for that particular purpose. Nowadays, you can have your phone. We have other devices where you connect basically your 3D model into the environment of where you do your fabrication part. The other aspect with the cloud is also you might have an 80-inch screen in your kind of environment where you have the cast unit projected, or other means to use this information to guide the workers on the factory floor to make use of this information what we created along the way. So here, for instance, our annotation service, you have basically in Trimble Connect the possibility to have your drawings, so to speak, connected with the 3D model, thinking of this also in the drawing state, that you have your 80-inch screen in the factory and where you have these information projected so that the worker doesn't need to use the paper, the printout, might be A0 and A3, very small, eventually broken or are not especially up to date, which is the worst. Outdated information. Here you have a platform to visualize the information up to date, and especially you as a user with access to the data can rotate, you can click, you can inquire, you have access to the information which others have created in such a meaningful way that you benefit from this and you have added value in the factory environment. And this is just one example. So over time, this will evolve so much more that things become more connected than ever, and it just takes time. And it, of course, it needs also the eagerness to try this out, and of course do a certain investment and have a learning curve. But there are great benefits to this, and we have various customers around the globe. They have done this, and they wouldn't like to go back once they have really seen the benefits what we are providing with this kind of way of working. Well, that's basically it in this given time I have. Wanted to give you a quick intro to what basically is doable in the precast concrete industry, and there's way more to do. So in that sense, I hope I switched on eventually some light on a specific field. I'm very happy to have a discussion or contribute more And in that sense, I'm saying thank you very much for your time and interest.
Thank you very much. Bye.
Thank you. Bye-bye.